So welcome to the session, the future of the LPWAN industry, and we're going to dive into low power wide area networking. Hold on 1 minute. All right, cleaner just came in. It's always a great time working at home. So Olivier, can you introduce yourself briefly?
Yeah, so I am Olivier Seller. I am 45 years old. I've been working for Semtech for almost 10 years now, since 2012, when Semtech acquired Cycleo, which is a company I co-founded with Nicolas Sornin, François Sforza, François Hédé, and that company is at the origin, is the inventor of LoRa. So I've been working on LoRa for more than, for almost 15 years, or maybe 12 years, and the first implementation of LoRa, the first test were from my home and from Nico's home. So that's what we've done. We've been working on that for a very, very long time now, and we are really happy to see the success and everything that came on top of it, the LoRaWAN, the networks, and so on.
Yeah,
the ecosystem. That's really great.
And did you expect that before?
Of course not, but it's great to see. I mean, I'm an engineer, so I've done a lot of R&D, and many things don't work or don't succeed, and sometimes they do come up with a nice success, and yeah, it's great to see that what I've designed or all the bugs I have introduced in the design are now replicated in millions.
Yeah, nice.
So, yeah.
Okay, well, hopefully we can get to that. Also, guys, everyone watching, please feel free also to drop questions in the chat. I'll keep an eye on that, and I have a list of questions as well. So it's really interview form. So LPWAN, low power wide area networking, where are we today, and what do you think is the future?
So that's so on a non-technical level. I believe the future for LPWAN is really bright, because we are part of the digital transformation of the world. So that's a long-term trend which is not going to stop. It's the technology is mature. But since it's a transformation of how people do business, of how people do industrial processes and so on, it's going to take a little bit of time. So really, the unknown is the time when a given market, when a given vertical market is going to mature for LPWAN and for LoRaWAN. But there's no doubt that we're going to be part, the ecosystem is going to be part of that digital transformation, and that we're going to be in many places in the industry.
Yeah.
So that's a bright future. So it's great to be part of it. We're really not to the end.
Yeah. No. Right. I agree indeed. And so technically, yeah, how far are we? So LoRa, it's great in terms of receiver sensitivity, low power, long range. Are we hitting the physical limits? What are we? How much is possible in the future, or is it, or do you think the biggest technical challenges are not really in the communications, but more in integrations and a way of thinking about the constrained devices?
Oh, exactly. There are a little bit of progress that we can make on the radio level, but really what we need to do is to build solutions that can scale. Because now the story, to mature, we need to scale. So that it's easy for customer to implement, to use, to deploy the solutions. So when it comes to technical improvements, what we need to do is bring technical improvements which is scale, because as far as long range, low power, and cost are concerned, we are in the right ballpark. So we can improve a little bit there, here or there, and we will discuss further. I think some features, some new features that are coming. But really, what matters most is to have something complete, well integrated, that can scale easily. That you can easily provision the device, you can easily roam the device, you can easily connect the device to an application, etc. That should be seamless.
Right. And okay, so so what is your contribution currently? So what do you do? You know, we see you. I think you know, we saw you last year also and at the Things conference, and I think people that are also members of LoRa Alliance also see you in your role as the vice chair of the technical committee. But what do you do on a daily basis, or can you share some of your ongoing work?
Oh yeah, certainly. So I'm really working on the for Semtech and for LoRa. I'm working on the physical layer. That's my main focus. My focus has always been modulation, creating modulation options, creating the demodulator, and then using the modulation in the most efficient way. So for instance, and that's something I've shared already with the technical committee, within the technical committee of the Alliance. I've worked on optimizing the number of repetition to improve range and also capacity. So maybe I can share 2 slides on that. Which is the button.
So that's interesting also, that the things that you work on, those are not the big technical challenges that we are facing in the future, right? So your part is done. You're basically making sure that the communication works and that range is good, low power, increasing network capacity. But the big challenges are more upstream, I would say, integrating it, ease of onboarding. Yeah,
I don't find the sharing button. Sorry, where's that?
Yeah, that's a good question.
There used to be.
Did we test that? I don't know.
Maybe not.
Well,
okay. Don't worry. So
we'll get to that. But we'll get help on that later. Let's continue. So
yes, that was it. So and also work on the new chips of Semtech. For instance, the gateway chips, the LR1110, the LoRa Edge chip. I'm working on point-to-point ranging features, better demodulator, and so on. That's really something which is a bit hidden, and that's a good thing, because if it's hidden, if people don't realize there's work on that, it means that it works fine, and the work is above. It's something else which needs to be. improved.
Well, it's the same for us actually. Same for me also. All the work that I usually do is also hidden. It's just packet routing. And if it doesn't work, then you'll see that. But if it works, then you just have your data in some charge somewhere. That nice.
People won't notice.
So you're also you're also working from home, I guess. Working on your laptop, and you say, I work on the LR1110. I work on chips. But what does that look like? What is the programming language that you use, or are you drawing chip designs, and how does your work end up from what you do on your computer to actually making the chips somewhere in a factory?
Oh yeah, so that's a long question. So it's that's something that's really interesting for engineers. It's the chip digital programming language. There are 2 languages. One is Verilog, the other one is VHDL. So Verilog is a really fun language. It's super low level. Once you know how to program in Verilog, you probably can design your own microcontroller. That's really exciting that you can do that. It's really low level. You have a clock signal. You describe a clock signal. You describe what happens when the clock on every clock edge. So that's fun, and that's a bit weird. And I also do a lot of scripting languages like MATLAB or Python, like most of us. And that's what I like most is not really coding, because I'm trying to do less and less. What I like most is really doing experiments, tests. So coverage test, geolocation performance test, Doppler resistance test of the modulation and demodulators. Well, any kind of test. And for that, I'm doing live test either in my home lab or outside drive test. That's
okay.
That's a lot of fun. Actually, you know, we've been locked down a few times last year, and I had the I had the right to drive my car to do drive tests during the lockdown. I had my paper saying that you're allowed to do experiments.
Nice.
From
Did you get stopped by the police as well?
No, I wasn't. But you know, I was driving a car with an antenna on top, and
so you can also
getting out of the car.
You can also break the speed limits, and you can drive faster because you need to test the Doppler effect. Or?
I did well. Actually, I did, but of course, I'm not allowed to do that.
Okay, cool. Hey, if you want to try sharing your screen again, it's the in the bottom you have 5 buttons below my face, and then it's the 4th button with the screen, and there you can do share screen, and then hopefully people can share side. Because I want to go back to indeed the models that you did and capacity and maybe the repetitions and SF. I've seen some of your work on that, and I think it's really nice if you can share some of that with this group.
So let's. Okay, so if I share my entire screen, so it's so.
Yeah, that works.
Do you see that? Yeah. So
I see it. I hope the audience sees it as well, but I guess so. Yeah.
So for a given power budget, that's imagine. So that the slide says for a given power budget, repetitions. Optimize range. Is that the slide you're seeing?
Yeah.
Yeah, okay. So every line here is for a same power budget, meaning you're either sending 1 SF12 frame or 2 SF11 frames or 4 SF10 or 7 SF9. So it's the same power that you're going to burn. Here is the success probability of receiving at least one of these frames. So these frames are repetitions. So either you have 1 or 2 or 4 or 7. And each color is for a different average signal level. So ranging from minus 132 to minus 142. And here you see that for many signal levels, it's better to repeat. And if your signal level is such that you would have 70% chances of getting a valid reception with SF12, then if you repeat, your success rate is going to improve up to 80%. And that's on a relay channel, meaning a very static device, non-line of sight static device with multipath. So that's really the case for a static device. If the device is mobile, I don't have the graph for that, but it's even better. So it becomes always better to repeat. But the conclusion of that simple graph here is that if you're a static device, it's close to optimum to repeat 4 times. So using SF10 here, because if you start from 60% success rate, you will be even at 60% success rate. But if your success rate at SF12, is higher, then you're going to increase that success rate. And if you're looking for 90%, 95% quality of service, then you need to repeat. It's going to be much better. And for instance, at 90% success rate, there is a one color difference. So SF10 is as good as SF12 here. It's actually slightly better. And the difference here is 3 dB. So meaning that by repetition, with the same budget, same power budget, you effectively increase range a little bit. Well, 3 dB is not a little bit, is a bit significant actually. Yeah. So that's repetitions are good. So ADR strategy should aim at repeating each frame 4 times. And I have another one which is on a different subject, so that repetitions also increase the capacity or the quality of service. So it's an example with only 5 channels, and you transmit long frames 7 times a day, and it's urban model with light indoor, 10 to 20 dB, so it's light to deep indoor, I would say. And here is the gateway density. So the more dense, the denser your network is, of course, the more capacity you have. Here, the capacity is expressed in density of devices, so number of devices per square kilometer. And you see that when you transmit several times, of course, you transmit more power, you have more frames in the air, so you have more collisions, but you have much more opportunities of getting the frame through than getting a collision. Therefore, you increase the capacity. And basically, if you double the number of transmitted frames, despite the fact that that the channel is more loaded, you almost double from one transmission to two transmission. You almost double the capacity. So that's pretty. I find it pretty nice to see that both from the capacity standpoint and the range standpoint, it's better to repeat. So that's one thing. So I can stop sharing.
Yeah, thanks. That's interesting, and that means also in practice, for example, for indeed network server vendors like me, that we need to change the way we look at ADR and not. And also end devices, by the way, they would rather send join requests 4 times at SF10 than one time at SF12, right? That's practically what that means. Yeah.
And also, if you're very mobile, if you really don't know where you are, it's better to send many frames at SF7 than 1 or 2 frames at SF12, because you're basically taking chances. If your channel changes that much, well, it's really a diversity strategy, like diversify your portfolio in on the stock market. It's really the same strategy. You don't put all your eggs in the same basket and take chances, and that's going to be more successful.
Yeah. Nice. Okay, so that's really interesting, and also good, good visual to show your work, right? So it's something you can really show.
So I have one more thing that I can share. It's about the new gateways, the 1302 and 1303 based gateways, and that's and maybe that's also going to interest the gateway manufacturers. I'm going to show you that. So the 1302 and 1303 are the new Semtech is offering. We also offer a reference design with that, which is really small. I'm going to show you that. So the 1303 has timestamp embedded. And here is an example of a drive test. So I'm telling you, I was doing drive test of the performance of the timestamp. So the gateway would be here, the green point in the middle, and here it's only point-to-point. There's a single gateway. It's not really locating, but I know where the device is. I know what the estimation of timestamp is. So when the timestamp is correct, there is no error. So the point is blue. And where the timestamp is too far, it's too big, too late compared to the reality, then it corresponds to this kind of errors. So here we see that when there are obstructions, potentially here, that's Neuchâtel. It's the home place of Semtech wireless and sensing, and it's really bad for timestamps and geolocation because it's hilly, it's unidimensional. There are a lot of reflectors here with masts of boats, sailing boats. That's really one of the worst places to do geolocation. So you can see that when it's really urban. So the distribution of the timestamp error is something like 50% of the cases it's only 50 meters, and 90% of the cases is around 200 meters. If you go to the in a suburban environment, it's much better. The timestamp error at 90% is probably around 60 or 70. And the rule of thumb is once you have 4 gateways seeing a device, the timestamp error is going to become your location error. So 4 gateways in such a urban environment are going to give you 200 meters roughly precision in 90% of the cases. So that's for the timestamp part, but as the 1303, so is computing timestamp in a much more efficient way, much more, much lower cost way than the previous reference design. It's not only doing that, so it computes one timestamp, one kind of timestamp metric per LoRa symbol, and at the same time, it provides the SNR of that symbol. So you can have history of SNR per for a given frame. So that's something I have never showed to well, I have not showed to many people. So here's my actually my place. So you see it's a little bit of houses in the neighborhood and many crop fields around. So it's mostly rural. And so that's drive test, where I was not driving too fast, except maybe here. And each of the color lines, the color doesn't mean anything apart from to distinguish them together, to distinguish them. But you see that the history of SNR per frame. So here you can see that the channel was not changing too much, but here, for instance, here you can see the channel was changing a lot. Here it was changing even more because maybe it was closer to the gateway, and shadowing was higher. The variations of shadowing was higher. So I'm showing this not only because it's fun to be able to look at a LoRa frame over time from a gateway, but also because I believe it opens innovation on the gateway side for edge computing, because with this amount of information, you can know whether a device is mobile or static, because if the channel changes, the device is mobile. So this may be of some interest to the network. You can also know if that packet was interfered. You can also know if that packet was interfered with another LoRa signal or something else. So you can do a lot of edge processing to improve the performance of the network. And that's probably a work that needs to be done on the gateway side, because there is so many information that a network server will not realistically be capable of computing.
Okay. So interesting. So you see, potentially that there's going to be some processing on the gateway, and that informs the network server, for example, about whether the device is moving or not, or what. Yeah. All right. Yeah. Interesting. Yeah.
Optimizing ADR, optimizing channel plan, optimizing gateway location. Well, anything which is about optimizing the network. The gateway knows much more than the network server. And here, with these new chips, we have more information. So these new chips bring more demodulators. They are capable of more parallel demodulation. They're also much lower power. Probably the chip itself is close to 20 times lower power. Well, with the same set of features, if you enable all features, probably only 10 times lower power. It's really small. That's the size of a gateway reference design with the 1302. That's smaller. It's cheaper, etc. So it's really a way to scale the network.
Nice. So talking about reference design, so we know gateways traditionally SX1301. I think that was your first generation concentrator. Yeah. There's the SX1308 that people maybe also know as the concentrator chip in the Things Indoor Gateway. Now you have the SX1302 and SX1303, and there's a reference design. Can you explain what is the reference design? What is it? If I'm a gateway vendor, for example, what do you get?
Well, you get a map, plans to build this or to integrate this in your gateway. So it's all already. Specifically, the radio part is working. So you can of course change it, improve it, but you have a starting point, and all you need to do is to build it, and it comes. You don't have to pay for it. Of course, you need to buy the chips, but the reference design itself is not is open.
Okay.
So that's really a way to accelerate your design as a gateway manufacturer.
Yeah. Hey, I want to go to the next topic, but there were a few questions that were asked in the chat. Chat is going really fast, but I saw a few questions coming by. One from Nick about the collisions. And he says, can you comment on if you have collisions how do you tell if there are collisions occurring in production deployments? So how do you know that? And a related question is from Björn Roskvist. I'm not sure if I pronounce your name correctly. It's, I think, a related question. He asks if all devices repeat messages. So if you have a lot of repetitions, will there not be more collisions? And would that not result in more power consumption on the network overall?
So I'm going to start with that one. So yes, there will be more collisions, individual collisions of frames, but the increased proportion of collisions will be offset in a positive manner by the increased chances of success. So if you're repeating once, so you transmit two frames instead of one, you have 2 opportunities of success. Of course, you're creating more collisions, but overall, in the end, it's better. And if you look at 5% collision rate, so not so many collisions, you effectively double the number of transmission that you can make to reach this 5%, which means you actually effectively you have 4 times more packets over the air for the same 5% collision rate in the end. That's one. That's not intuitive. But that's really nice. What's nice with statistics? So it's usually counterintuitive. The only thing to do is either try or simulate. But that's.
But this you also have to simulate, right? Because around your house, I'm not sure where you live, but it looks like a rural area in France. You don't have that much LoRa traffic around that's creating a lot of collisions. So you need to simulate this, right?
Of course, you need to simulate, and I think operators who can observe collisions today are really happy because it means they have loads of customers because it's really thousands of devices per gateway you need to start seeing a fair amount of collisions, and we're in many places we're not there yet.
Yeah.
So yes, we need to simulate because the capacity of a gateway is tremendous compared to to what you need to sustain a network.
Yeah.
And then the other question was, how do we observe collisions?
Yeah.
So on the network server side, you can track the packet counter, and if you miss one index in the frame counter, then it means you've lost this frame. And if the other frames have a good SNR, a good RSSI, then it's likely that a collision or an interference made this packet loss.
On stationary devices.
And on the gateway side, it's slightly easier because the gateway has more metrics. The gateway can know when it knows which reception attempt it tried. The gateway knows if a header was received correctly, but not the payload. So there are more metrics on the gateway side to find out collisions.
Yeah. Okay. Next, I want to go to the new so to say modulation. What people know maybe as LoRa-E, LoRa Evolution. It's now called LoRa FHSS, frequency hopping spread
long
spectrum.
Range.
Yeah.
Long range frequency hopping.
What is it?
One picture to show what it looks like. Do you see my screen?
Yeah.
Okay, great. So thank you, Johan, for your introduction and on LoRa. I remember on Monday you showed one graph like this.
Yeah.
So be an SF12 frame, so chirps, up chirps, down chirps, modulated chirps. That would be an SF7 frame, so we need to zoom in to see anything, but and below that would be an LR FHSS frame. So there are many differences and there are commonalities. So to start with the commonalities, it's spread spectrum. So the information is spread in frequency. So LoRa is chirp, spread spectrum, so linear frequency increase versus time. And LR FHSS is frequency hopping. So we stay on a given frequency and then we hop. The first 3 longer hops here correspond to the preamble and header. And that part on LoRa would be this part. So the first unmodulated symbols, synchronization symbols, and then the first part here, which tells the length of the payload, etc. And then the rest is the data. And you see that it's slightly lower data rate than SF12. It's the two frames here, well, the 3 frames here have the same payload length. So it's slightly lower data rate. And the good advantage, really the advantage of LR FHSS is that it has higher capacity compared to SF12, because this hopping sequence is random. So you can definitely put a lot of such frames in parallel and receive them on the gateway side. So that's what we've designed this for. So it's higher capacity than SF12. It's not really higher capacity than SF7 because SF7 is really shorter. So you could stack a lot more, and you have many different channels to do so. So that's a bit different. But compared to SF12 or SF11, you have more capacity. So it's really good. No, I'm back to unsharing. So it's really good for when you need range, when you need a lot of devices at that long range, and you cannot afford to put more gateways, because if you put more gateways, the ADR will be able to so yeah, FHSS is a part of some gateways reference designs. Not the 1303 or 1302, but the V2 reference designs are compatible with LRFHSS.
So that's okay.
So sorry, back to the interest. So the interest is really when you don't have a lot of gateways.
Yeah.
And need long range and a lot of devices for that. So one very good example for that is satellites.
Yeah.
Satellites, you don't have a lot of gateways because you don't have a lot of satellites. You don't have a lot of transmit power if you're using the unlicensed bands. So you need the long range, and almost all devices would be at the equivalent of SF 10, 11, or 12, talking to a satellite. And there you need the additional capacity. The other example would be maybe smart cities, because it's operating network from a limited number of places, and you're talking to loads of deep indoor nodes. So that's the other example.
Okay, and do you need other devices? Can I use existing LoRaWAN devices, or do I need a new antenna, or do I need a new chip? I know the answers, but I'm just going to ask you anyway.
Yeah. So to talk to a satellite, you probably need a special antenna, or at least an antenna that points to the sky. But apart from that, you can use existing Semtech or STM devices. So all of these, starting from the SX1301, all these devices can have this LRFHSS modulation.
Interesting. And it also is now part of the regional parameters, right, in LoRaWAN. So there are, it's a new band so you have EU A68 for traditional LoRa, traditional data rates. And there's also now, if you want to use FHSS, then you need to account for that on the end device on the LoRaWAN level, right? Different data rates and things like that.
Mm-hmm. Yeah, so it's part of the. It's no part of the LoRaWAN certification. It's a different channel. You create a channel with that data rate. But it may be overlapping. It may be the same on overlapping the bands of existing LoRa channels. Because since the modulation is different, it's not going to hurt a lot. Or you can create a channel which has different frequencies. That's up to you.
Yeah. Cool. Hey, next is I want to go more about so talk about more as your role as the vice chair of the LoRa Alliance Technical Committee. So we also know each other from the Technical Committee, right? We sit on the same meetings, and but can you explain to people watching a little bit more about what does the Technical Committee do, and what is the role, and how does it work?
Yeah. So obviously the role of the technical committee is to produce technical specifications. So it produces all LoRaWAN, LoRa Alliance technical specifications. And usually for each technical specification, a dedicated subgroup is responsible for that specification. So there's one for the protocol, which we call LoRaWAN link layer, and that's probably the most known, well-known specification. There's one backend interface specification. There are a set of specifications for multicast, firmware upgrade over the air, application package discovery, and probably there's one specification, of course, for regional parameters, which how you adapt the protocol to different regions in the world. And we are now working on more specification, but for instance, application server to network server interface, but that's going to be part of the backend interface, very likely. We're working on relay, so expanding the specification to add relay operation, so from a device to a relay to a gateway. That part we're going to add. And that's we work with face-to-face meetings when we have the chance to do that, and a lot of web meetings now. We have, of course, a collaborative platform to do that. We are open. The technical committee itself is open to sponsor and adopter members of the LoRa Alliance, and the working groups are open to all members of the LoRa Alliance.
Yeah, sponsor and contributor members of the LoRa Alliance. Yeah, you can join the TC.
For the technical committee. Yeah. For the technical committee, but for the subgroups, for task force, it's possible for any member to join.
Yeah. And nice. So I have one more question about the FHSS coming in from Michael. He asks, are there already stacks that are supporting FHSS for the end devices? Do you need a special version of LoRa Mac Node, for example, to use this? Or how does that work practically if people want to use this?
Yes, you do. That version is not available yet to anyone in open source, but for interested customer, we have a first adopter program that so people can experiment with it. So of course it's working. There are gateways that receive LRFHSS packets from many gateway manufacturers, and there are satellites which receive LRFHSS packets from our chip. So it's available. It's not completely publicly available yet. We are in adoption and trial phase.
Right. And then a follow-up question from Daniel about the bands to use. And I think that's a really good question also, because we know, worldwide, there are different regions defined in LoRaWAN, and that's also because the sub-gigahertz ISM band is not harmonized. So in the US and in Europe and in Asia and everywhere, you need to use different frequencies. But if you're talking about satellite communication, how does that work? Because these satellites, they fly all over the world. Are they switching frequencies, and what does that mean for end devices? Can they still transmit on the frequency that they are certified for, or is there another frequency that they use?
No, so exactly, the satellites will switch their receiving frequency and the transmit frequency also, whenever they transmit, but so far the satellites only receive. I forgot to mention that LRFHSS is an uplink only technology. So on the downlink, you still need to receive with LoRa, because LoRa is much easier to receive. You need a gateway to receive LRFHSS for complexity reasons. So the satellite knows where it is over Earth. It knows its flight plan very precisely. So it knows if it's over Europe or over US or over Asia, and then it will switch accordingly its frequency of operation. The end device just do the same as they were doing with the terrestrial network. So they need to use a frequency which is authorized, license or unlicensed in the region they are operating.
Okay, so the satellite knows where it is flying over Earth, and then it just switches frequency to listen on, basically.
Mm-hmm.
Okay, so yeah, we're going to wrap this up. One more thing about what you said in the beginning about the challenges. There's more in integration, onboarding, and things like that. What is really the role of LoRaWAN here? Because LoRaWAN is also, a standard for transporting data, but it doesn't specify what the payload format is to use. So it's not like lightweight M2M or something that it says, okay, you have to, if you want to send a temperature value, then it has to be in this format. So that is open. So it also creates a lot of new, freedom for device makers. Is that a good thing or a bad thing, in your opinion, if you talk about, ease of onboarding, ease of integration? And what does LoRaWAN do to make integrations and onboarding easier?
So first of all, LoRaWAN is mainly defining transport layer. I think it's a good thing because it's a way to have economies of scale in the networks. It's not really interesting to have a nationwide network coverage for one for metering, one for asset tracking, one for smart industry, one for smart cities. It's much cheaper to have one network to fulfill all these applications. So that's the reason why it's been defined like that, separated from the application. Then, of course, LoRa Alliance is working on adaptation layers or ties with existing protocols. So, for instance, we're working on having wireless M-bus over LoRaWAN, DLMS over LoRaWAN, some IP V6 header compression, so that IP can be over LoRaWAN. So all this vertical application, well, if you can call IP a vertical application, but it's a way to integrate with any application, and the role of the LoRa Alliance is then to make this interface, this integration easy and work. The other role of the LoRa Alliance is to make our set of specification complete, so that everything is specified. So anything is interoperable with anything else. We're on this path. For instance, there was no gateway to network standardized interface, so we're doing that in the LoRa Alliance, so that any gateway right out of the box can be plugged to any network server, which is operational. And I'm sure that TTN is going to like that, because it's going to make your life and the life of your users and customers easier.
Yeah, for sure. And that brings me to my final question. So what are the top things that the LoRa Alliance is going to work on in the next few years? So what are the most important things that are now on the roadmap? We saw, the release of LoRaWAN 104 last year, and the certification test tool. And I think that's super helpful for device makers. You already scratched the surface on a few things, but what is, in short, what are the next priorities for us in the LoRa Alliance?
So in short, we are going to publish, I hope, by the end of this year, the next version of the LoRaWAN protocol, version 1.1.1, which is going to bring security improvements. So we're going to apply good practices in security. It's not that the previous version is broken; it's just that it's better. It's also better handling confirmed frame. For instance, you know which frame you're confirming, etc. It has so on top of better security, it has active roaming, so handover roaming. So today we only have passive roaming. That's good enough. But handover roaming is a way to further optimize the networks when a device is roaming, especially internationally. And we are improving a little bit Class B, and we will be adding a couple of features by the end of the year. So that's really that's going to be a milestone for performance, and I think that people will migrate naturally toward this version pretty quickly. We are also working on adding relay and device to device operation, which is really a market need. So relays to completely to expand coverage at a low cost, and especially at a low cost without power. So battery operated relays. So that's the cost of installation, which I was thinking about. And device to device is a way to control directly with low latency, and sometimes even without the network, from a sensor to an actuator in case of alarms, in case of whatever. But we have needs for that, and we are going to work on that. And as I said, we're going also to finish the puzzle of our certification set by doing a gateway to network server interface and also a network server to application server interface.
Yeah. Well, those are 4 really interesting things and important, I think, for the ecosystem.
Yeah.
All right. With that, I want to thank you very much, Olivier, for your time. And there are a few more questions also in the chat. But I think the best thing that people can do is to reach out to you here on Hopin. I would like to ask if you want to join, maybe later today at one of the networking events, the informal networking events, where also people can ask additional questions to you. It's great to have you here. And you want to say anything else before we stop?
No, thank you, Johan, and congratulations to this for organizing this conference. It's really great. Really appreciated. Thanks a lot.
Okay. And Leo, this is a real flower. I got it from my mother, so you know. All right. Bye.
Okay. Bye to everybody, and we can meet on the booth, on Semtech booth. Bye.
Bye.